Hello everyone. Today we are going to learn 2.3 misleading graphical representation of data. So learning objective here. So this section, I brought the textbook here so we can just go over it together. All right. So any statistic, they say that the graph can sometimes be misleading. So let's take a look. We have example 1, data table 12. The associate degree awarded in thousands and it's clear here. And this the degrees awarded, right? So between 2018 to 2019, 1,037. And between 2019 to 2020, there is 981. And then this is the graph. So what can you see that? Right? Looks like this is way more degree awarded, isn't it? Right? But their difference is just a little bit, right? So their difference between only the 56 here to here, right? But then look, looks like their difference is between, I don't know, more than, yeah, more than, I don't know, 100, more than 1,000 looks like, right? Yeah. But actually is 1,037. One is a little bit less than 1,000, right? Okay, so let's take a look. What's the misleading for the graph? Okay, so they say that the bars are not proportional. So in that case, proportional, talk about relative size, their size. And then the text will indicate that they don't start to zero, right? Okay, if they start to zero, then look, 981 and 1,037 bars are proportional, yeah, proportional, right? Yeah, so that is misleading. Okay, okay, now we have this one, but let's read the tip. Important point. It is important to use zero. We have to use zero. On the vertical scales of any bar graph or histogram to keep the bars proportional. Yeah, makes sense. Yeah. This allows you to fairly represent and interpret the difference in frequency or relative frequency between categories. Okay, now let's looking at this one. What is misleading this graph? The crime rate per 100,000 people from 1,099 to 2018. Okay, take a look at this one. Okay, the solution say that, yeah, we just learned that, right? must be 0 here, right? Okay, if we have 0, let's take a look. 0. 0. Then they say that this is not dramatically lower. So this one from here to dropped, right? Looks like a dramatically dropped, right? But from here to here is not if we are using 0, right? And then if we are using 0, then the graph more flatter. So it does not exaggerate the crime rate difference. Make sense? Okay, let me highlight. So no dramatic, not as dramatically low. Yeah. And then not exaggerate the crime rate difference in that case. If we're using 0. Yeah. All right. Okay. How about the next? We have graph. Which one? What is the misleading about this bar graph? Can you take a look? A problematic bar graph. Okay, let's take a look. They say that, can you guess what this bar graph represents? The bars are not labeled. So we can tell the tallest bar is taller than the others. But yeah, I want to make a period. But what does each bar stands for? Yeah. So we just know that their sides. That's it, right? The vertical axis level, like a scale, 0 to 25, 50, 50, 75, 100. So we know that the frequencies, right? But then we don't know what is for, right? Yeah. No information at all. Oh, and then they mentioned that is a percentage. It could be, right? Because 25, 50, 75, 100, it can be just number or percentage, right? Yeah, frequency. Oh, yeah. Is it percentage or frequencies? Yeah, I thought I'll say first frequencies, but it's not. It might be a percentage, right? So there is no way to know. This graph is useless. Yeah, no information at all. Yeah, okay. Okay, so now looking at this graph, the data represent the median cost of a single family home in the US. What do you think? Okay, right. So we have 2002, 3, but then now 2011, 2012, 13, 14, then jumped 2021 and 2022, right? Yeah. So let's take a look at the solution. They talk about jump, jump of years, right? So then you can see the price have increased, but then spikes was not as severe or sudden as it was dramatically shown in the first misleading graph. Yeah. So because the time goes by, right? The median home price, yes, it's increased, right? But then they missing the years in this part. But this part, not much change there, right? But this part is dramatically changed, right? Yeah, because missing some years, right? Okay. Now, so this is the actual the graph, median home price in US. So here is important point, histogram and time series plot and the horizontal axis. The histograms and time series plots must have correctly spaced horizontal axis. That means the increment marked on the horizontal axis must be marked with equally spaced tick marks. Failure to use correct spacing will distort the distribution or trend in the data. So we have a number line, right? So this is 0, 1, 2. These are tick marks. Yeah. Okay. Now we have a pie chart. What is misleading there? Okay. We can see that, right? So this is 22%, this is 17%, 18%. So 18% looks like bigger than 32%, right? Yeah. And then 22% looks like way bigger than 17%, 18%, even 32%, right? Yeah, that's the misleading. Yeah. So the correction of the pie chart is 11%, 22%, 32%, 17%, 80%. Yeah. Okay. How about this? Yeah. What is the misleading? Yeah, over 100%, right? It should be 100%, right? So it's a 193% there. Oops, I did not see, you did not see, huh? 193%. Okay, so there is an important point, pie chart. So pie chart can only be used to show qualitative data. We talked before, right? With no overlapping categories. The area of sectors or slice must be proportional to the size. So we talk about the proportional, like relative with the size, right? The total of percentage should be 100%. So sorry, you guys did not see the important point. So sorry about that. Yeah. Okay. And then they have, you should always be wary of pictography. Yeah. So what is a pictography? Pictography is a picture intended to be partly entertainment, but that includes numerical information. So here is pictography. Ooh. Okay, so let's take a look. This one. Okay, they say that this is a pictography of top orthopedic injuries in children requiring hospitalization. Zation, zation, zation. Okay, let's take a look. This is a thigh bone, 21.7%, lower leg, and then upper arm 17%, and lower arm 14.7%, and spinal 5.2%. Okay, what is it telling us, right? What is misleading? We don't know much about that, right? Okay, is a cute picture? No, it's not. Is this cute picture? Okay. What they say that, oh, yeah, like proportional, yeah. Okay, let's take a look. Uh, Spinal 5.2% and thigh bone 21.7%. Two of spinal crutches should measure 10.4%, but that appears longer than 21.7% for thigh bone injury, right? Okay, so let me read this one. Using crutches for the bar gives a scene that like a bar graph. Okay, makes sense, right? But does the bar include the handle? Yeah, this is looks like a handle, right? Or just a shaft. It's difficult to tell. Regardless, the length of the crutches are drawn. One would suppose to make a picture more attractive to the eye. There is no scale provided. Yes, right. We can't use the length of crutches to compare the injury categories. So for instance, the crutch for spinal injury at 5.2% looks like it's too long. So the picture look, so this is 5.2%, right? So if we image there's one more 5.2%, then this should be 10.4%, right? But then look, thigh bone has 21.7%, which is smaller than 10.4%. So this is not good picture of that, the bottom line. Yeah, okay. So there is an important point for pictography. Pictography are type of chart that use image to convey data. The images are not generally not displayed using correct proportions. They are created to grab the attention of a reader because picture, right? By creating eye-grabbing and pleasing but potentially misleading picture. Yeah. Okay, now this will be the last one. Nice picture too, pictography, right? Okay, can you please read? Uh, Not read, can you please take a look? What's the misleading in that case? Cute. Oof. Oh, Yellowstone. I've been to Yellowstone. Yeah. Have we been to Yellowstone? So beautiful, huh? Yeah. So I've been to Yellowstone and then that area, like horseman shoe and Antelope Canyon. So beautiful, right? Yeah, you should go if you have not gone. Yeah, so beautiful. Recommend. Grand Canyon is number one. I never been to Yosemite. I should. Close. I'm living in close by, right? Okay. Um. So what's the misleading about this pictography, right? Okay, let's take a look. The bigger one, approximately 528, and in 2019, and approximately 264 in 202, right? Uh, let's take a look at the solution. Uh, so they said exactly double size, 2002, 264 to 525 is double size. The off from 2015 twice as tall as of 2002, but would be about 8 times the volume because it's also twice wide and twice as deep. If the smaller wolf weighed 10 pounds, the larger would weigh 80 pounds, even though we don't think that when we view image, we tend to feel it. That is how this type of graph can mislead. The use of picture instead of a simple bar graph is attractive, but makes the increase in population appear to be more than doubled. A time series graph, even at a bar shown, would fix this problem. Okay, yeah, it's a cute picture. Yeah, this is I can consider a cute picture because of, right? Yeah, looks like a dog. And then size-wise, they looks like a double. And then the number is double, they say that. Okay. Uh, but then since they show the picture of wolf, right? Looks like their size also bigger, right? Size is bigger, the height is taller, right? So what if without picture, we can just see that the gray wolf population in Yellowstone, right? National Park. We can just see that they're increasing. It's doubled as a population size, right? Yeah. So also this is a bar graph of the population of that wolf in Yellowstone, right? Make sense? Okay, we are done for this section. Thank you for watching. I will see you in the next section. Bye.